We're on Pythagorean identities for 1.4. Pythagorean identities are just the rules that come from your x squared plus y squared equals r squared situation. And so these are our Pythagorean identities. There are proofs that go along with them. We're not in a class where we have to do the proofs and evaluate them, but it comes from the understanding of us keeping in mind your y squared plus x squared, and the radius is r squared, right? So in this case, you are looking at the unit circle, and y squared plus x squared equals 1. That's because sine is always your y, cosine is your x, and it goes from there. Identities are expected to be memorized for the most part because you're gonna have to use them along the line. And yeah. I need to remember, put in a work order for your laptop. All right, let me know when I'm good to go on. Okay, I'm gonna go, but remember, these are also available for you to view on your Brightspace. Okay, our next identity are quotient identities. Our quotient identities are also come from our unit circle and talking about the radius at a point. So remember, we learned that tangent given a point equals your y over your x. That's where this comes into play. Your y is your sine, and your x is your cosine. And then because cotangent is a reciprocal, and we also know that when we learn cotangent theta equals x over y, same thing here, cosine over sine, x over y. So your x comma y is the same thing as your cosine comma your sine. The way I remember it is to think it as in alphabetical order. X, Y, C, S. I'm gonna stay in alphabetical order. Okay, and just like any other fraction, when it's in this setup, your denominator cannot equal 0. So it's okay to have 0 in the numerator, but it's a no-go to have 0 in the denominator. Bless you. All right, so we're gonna now, keeping these identities in mind, we're going to look at situations where they may be applied. So up first, it says find sine theta and tan theta, given that cosine theta equals negative square root of 3 over 4, okay? So given the fact that my cosine theta equals negative square root of 4, there's a couple ways that I can approach this. I can think about it in terms of x, y, and r, where I'm finding my x, identify my x, finding my y, and identify my r. I can think about it in terms of the previous problem where we have our identities, and I know that I can find sine squared by the fact that this has to equal 1 because cosine squared times sine squared. We're going to do it that way to show you. The other thing here is it tells you that sine theta has to be greater than 1. So sine has to be positive. Does that make sense? So if sine is greater than 1, that means it has to be positive. That means that the only quadrants that our angle can lie in are in quadrant 1 and in quadrant 2. Yes. I said 1, greater than 0. I didn't mean to say 1. Thank you. Sine theta is greater than 0, which means that it has to be positive. Okay. Sine represents y, and y is only positive in quadrant 1 and in quadrant 2. Okay. So that means that if it falls in quadrant 1, then sine, tangent, and cosine would be positive. However, our cosine is what? Negative. So that means that our angle falls in quadrant 2. So quadrant 2 is where everything is satisfied. Cosine is negative and sine is positive. And because of that, we know that our tan is going to have to end up being also negative. Okay. We're going to use our Pythagorean identity to find our sine. So Pythagorean identity says that sine squared theta plus cosine squared theta equals 1. Is that what we just wrote down? Okay. So we're looking for, we don't know sine squared. We're going to bring that down. But do we know our cosine? Yes, our cosine is negative square root of 3 over 4 squared equals 1. Okay, so we're going to evaluate. We'll simplify this term right here. So when I'm simplifying this term, that means I'm going to do it over here, or in my brain, I'm doing square root of 3 over 4 times negative square root of 3 over 4, right? Because it's squared means I have how many of them? 2 of them. A negative times a negative is a positive. A square root times itself sets itself free. Agree? 4 times 4 is 16. So this simplifies to become 3/16. Are you still with me? Okay, so I'm going to replace that. So now we're at sine squared theta plus 3/16 equals 1. What do I need to do to get sine by itself? Subtract. So I'm subtracting 3/16 from both sides. In order to subtract when you have a fraction, it must have what? A common denominator. So that would be 16 over 16 minus 3 over 16. 1 is magical. I can manipulate 1, right? It can take shape and be in different costumes. So we're left with sine squared theta equals what? 16 minus 3 is 13/16. Agreed? All right, last thing is to take the square root because you just want sine. So I'm going to take the square root of 13 and I'm going to take the square root of 16 because when you take the square root, it applies to the numerator and to the denominator. So now we have our sine. So sine theta equals the square root of 13 over 4. And that is our sine. Okay, so to find our tangent, we're going to use our quotient rules, and that says that tan theta equals sine theta divided by cosine theta. Do I know what sine and cosine are? Yes. So tan theta equals, our sine theta is the square root of 13 divided by 4. Our cosine theta is the negative square root of 3 divided by 4. How do we divide fractions? Anyone? You're doing something with reciprocal. You multiply by the reciprocal of the divisor, right? Or keep, change, flip. Does that ring a bell? Keep, change, flip is just like the little cutesy way of doing it, but you're multiplying by the reciprocal of your divisor, your denominator. I don't know why I couldn't think of that word that fast. So we're going to keep the numerator. We're going to change from division to multiplication. And we're going to flip our denominator. So instead of negative square root of 3 over 4, it's going to become negative 4 over the square root of 3. And now you have to simplify this. What happens to your 4s? They cancel out. 4s cancel out. And I'm left with negative square root of 13 over the square root of 3. Am I allowed to have a radical in the denominator? No, so I have to rationalize. How do I rationalize that denominator? Perfect. I'm going to multiply the numerator and denominator by the square root. And that's going to leave us with negative square root of 39 over 3. I cannot break down 39 because 13 and 3 are both primes, right? They don't break down. There's no perfect squares present. So therefore, my tangent equals negative square root of 39 over 3. Okay, so we applied two different identities here. We applied our Pythagorean. And that's because I had cosine and I needed to find the sine. Then we applied our tangent, our quotient, to find tangent because I knew my sine and I knew my cosine. So that's the purpose of using those identities. Okay, questions, comments, concerns. Okay, it is a different use of your math skills, and you are applying your sine and cosine and tangent outside of the norm in geometry. Okay. All right. So be careful to choose the correct sign when your square roots are taken. Okay. And we did that because we pre-checked what our value had to be because we knew what quadrant we were falling in, right? So when we are looking, I'm going to make sure that everything is true. So if I'm in quadrant 2, the only thing that should be positive is sine and cosecant, right? When I double check in quadrant 2, my sine is positive and my cosine and tangent are both negative. So that makes it an applicable answer for this quadrant. Okay. Outside of that, that's what, just be careful when you're taking the square root. Okay. That's why I like to determine beforehand what my signs should be, so that as I'm going through the math, I know that I'm gonna stick with it through that. Okay. All right. Here it says the sine of theta and cosine theta using tan of theta equals 4 over 3, and theta is in quadrant 3. Okay, so it's telling us that theta is in quadrant 3. So if I'm in quadrant 3, that means that I have a negative x and a negative y. Because of that, that tells me that sine and cosine are both negative, right? So I'm going to have a negative cosine and a negative sine. All right, so if I'm looking for 4 over 3 and it falls in quadrant 3, all I can use is what I know about tan theta, okay? And we know that tan theta equals sine theta divided by cosine theta. So in the case of this problem, what is my numerator? 4. What is my denominator? 3. But because they're in quadrant 3, what do I know they have to be? They both have to be negative. So my answer is sine theta equals negative 4 and cosine theta equals negative 3. And I am done. I have nothing else to go off of. I only use the information that is given to me. Okay. And this is because I applied the quotient rule. How do you feel? Good? That's where making sure you pay attention to the quadrant and what should be positive. So again, goes from there. All right, here we go. We are going to now use a different Pythagorean. We're using tan squared theta plus 1 equals secant squared theta. Then we're going to use reciprocal identity to find cosine theta. All right. So here we're given well, that's just easy. If we're given the graph, then you have your X, Y, and your R. It's really not a whole lot to have to worry about. Just saying. All right. So if we're given all of our values, I don't know what they wanted us to do here besides just use what's given to us. Well, remembering what cosine theta is. What's cosine theta? In terms of X, Y, and R. X over R. So if cosine theta is X over R, and we have those values right here, we're going to end up with negative 3 over 5. And if that's our cosine, what is our secant theta? Unless I'm missing something. They gave me a picture and they gave me a problem, so. I would just use what the picture tells me. Use what I already know, X, Y's, and R's. Okay. It would have to have something more. I guess if it didn't have the picture, well, it has the picture, but if it didn't have the picture and it just wanted you to find secant theta, then you would just get secant by itself because you're just manipulating that. Just take the square root. So then in this case, I would have to take the square root. When I do to one side, I do to the other. So we would know secant theta equals the square root of tan squared theta plus 1. Until I find, I can't go any further. I don't know what tan is. I don't know what secant is. So if there was no picture, then you would just be getting your trig identities by themselves. Yeah, if it asks you to isolate. Yeah. All right. So that is it for chapter 1.